Hello YouTube, welcome back to my channel. I've got the rest of this gold-filled scrap here that I've accumulated over the last 2 months. I've been saving it up, and now today what we're going to do is we're going to get some acid on this, dissolve out all the base metals, and get some pure gold from this gold-filled scrap right now. This gold-filled scrap is what I've accumulated over the last about 2 months. When I go through the scrap that my wife gets for me, if I find some pieces of gold-filled stuff, I just set it aside until I accumulate enough to make a nice size batch and produce a decent size ingot of pure gold. And I've spent the last 2 days picking through this, taking out all the stones, all the steel, and cleaning this stuff up. And now it's all ready to be incinerated and put in some acid so that we can recover the gold foils from this gold-filled scrap into this little bin here so we can weigh it up and calculate a yield once we get done here. I'm going to weigh it up now. Here's our scrap going into the melt dish. We've got 417.3 grams. Alright, just like before, we're going to start out by adding about 200 milliliters distilled water to this big beaker back here. I'm going to turn the heat on to get it started. Then we're going to take a torch. We're going to burn the people off of this material here. This incineration step is highly important. It's going to burn off all the oil and grease from that metal. I want to burn this carefully. Avoid melting it. If it gets melted, then it'll have a tendency to try to alloy with the base metal. And then when we put it in a nitric acid, that material will come out as a purple mud, which is not bad, but the purple mud is harder to recover, and we could experience loss of metal easier dealing with that mud. Lead or tin soft solder is sometimes used in gold-filled jewelry, so we want to watch out for the presence of that. If we see any silvery metal melting and staying molten just from the heat of the melt dish, then we want to stop the incineration and remove that metal before we proceed. Should do it. Now what we're going to do is take it here and put it up inside the beaker here. Just dump it right in. There's water in there to cool it off. Just carefully dump it in the beaker here. Alright, I've got another batch here. I had so much I had to split it into 2 batches. So we're going to go ahead and burn this now. Same thing, burn it until no more combustible material will come off there. So it quits smoking essentially. It cannot be overemphasized how important this incineration step is here. We don't want to melt this material, but we want to keep an eye out for anything that does melt, indicating that it may be tin or lead, and we want to get that out of there. The material will have oil and grease on it. and dirt from people wearing the jewelry. And what we're doing here is burning all of that gump off of there. If we don't get it all off, then what'll happen is we'll get some oily residue building up inside the beaker. This incineration will completely eliminate any kind of oily residue inside the beaker. We can tell when this incineration step is complete when we see it quit smoking. That should do it. We'll take it and put it up in the beaker just like we did the last group. And we'll have everything in here now. Alright, this is the about the third batch that I've refined in the last 5 days. I'm adding some more distilled water here until we make sure we got enough hydration for this. It's about a half a liter. There's probably 750 milliliters of distilled water in there now. In this flask I have some used nitric acid from my previous gold-filled refining video. And I'm going to add that to the beaker now and start this ball rolling here. This is used dilute nitric acid going in to the gold-filled scrap. See, we get an immediate reaction there. The time right now is 7 p.m. and we just kicked this reaction off. We'll just sit there and let this heat up and dissolve those base metals out now for this third gold-filled scrap refining video. It's about 20 minutes past 7. All that nitric has been used up. I've got my addition funnel set up here. And what I'm going to do now is add some concentrated nitric acid to this funnel right here. I've got the funnel full of about 300 or 400 milliliters of concentrated nitric. I'm going to turn the drip flow on here, and we're going to start feeding some concentrated nitric acid down into our reaction beaker, a little bit at a time. Start dripping it in a little bit at a time here. With this apparatus, I can carefully control the amount of nitric going in. Okay, here's a look at my addition apparatus. That's concentrated nitric acid in there. I use that stopcock to regulate the flow. The key issue here is getting the acid in as quickly as possible without causing that beaker to boil over. And by dripping it in real slow like this, I can achieve a balance between the amount of heat that I'm adding to the beaker and the amount of acid that's slowly being dripped in there. Based on this amount of gold-filled scrap, 417 grams, I'm going to need in the neighborhood of around 12 to 1300 milliliters of concentrated nitric acid to get all that, all the base metals dissolved out of this gold-filled scrap. It's been about 15 minutes since I started the acid flow here, and I've got a pretty good balance of heat and the flow of acid going into that reaction vessel there. Pretty much on autopilot here. Just got to keep an eye on it so the reaction doesn't get too vigorous, but right now it's looking pretty good. It's in balance perfectly. The time right now is 9 p.m. and I'm watching the last few drops of concentrated nitric make its way down into that beaker there. I haven't had to touch it. This is like a dream. It's absolutely like a breath of fresh air, man. Here it's about 9:30 p.m. It's getting late. I'm going to go in and knock off, get some rest. I'm going to take the apparatus, the delivery tube out, and just let this boil now for about another half hour, 45 minutes. Shut her down and call it a night. 8 a.m. the following morning, got a good night's rest. Turn the heat on, reinsert the delivery tube into the beaker. Then I pour another half-liter charge of concentrated nitric acid into my delivery apparatus. I adjust the stopcock there to reestablish the flow of acid into the beaker. And then I want to add a little bit more distilled water here to rehydrate that. Distilled water provides a medium for those base metals to dissolve into. And you're seeing the last few drips going down into the beaker here. This is nitric acid coming out of my funnel. And so now I've got about 1 liter of concentrated nitric in on top of that gold-filled scrap. I've got about 1 liter of concentrated nitric in there. Let's go ahead and take this off. I'm going to take a look at what we got down in here. Oh yeah, look at them gold foils starting to, that's looking real good, man. That's exactly what we want to see in our gold-filled scrap. Those foils, the base metals are getting dissolved out of there, and it's looking really good. Look at that. Those are gold foils with all the base metals removed. We'll be able to refine this into a nice ingot of carat gold, or pure gold. All right, I added another about 150 milliliters of nitric acid there. Got the flow reestablished. Once we get this in, I'm just going to leave this on the heat and let it boil. Trying to get those fumes to clear up inside that beaker, and that'll let me know that I've got all the base metals dissolved out of the gold-filled scrap. Got about 11 or 1200 milliliters of nitric in there now. I'm going to take our drip tube out. And we're just going to let this boil now until all those fumes clear up. Then we're going to take it off the heat and go from there. Here you can see the gold foils have begun to float on the solution. That's a good sign. That means all the base metals have probably been removed from those gold foils. Okay, I get to go down and spend some time with my good friends Paul and Bubba. So while I'm gone, I'm going to pull this down off of the heat, and we're going to let this cool down, and when I come back, we'll get that solution off of those gold foils. Alright, just look at these gold foils. This is coming along real well. Look at that. Those are just shells of gold that used to be in base metal. Just shells, light. And this is looking real good. While I'm gone, to let this cool off, I'm going to add half a liter of distilled water to dilute that concentrated solution. I just got back from my lunch with my good friends, Paul and Bubba. We've solved all the problems of the entire world in an hour and a half. Now, if we could just get everybody to listen to us, the world would be fine. I've got a little bit of sample of our solution here, and to show you, this is going to have some silver in it. I'm going to pour some hydrochloric acid in. If there's silver in this blue solution, I'll get a cloud of silver chloride forming. Here we go. And as you can see, there's lots of silver in this one. Lots of silver in this one. So I'll want to save this blue solution back here. It's got a lot of silver in it. Now I'm going to filter our solution off of our gold foils. Okay, here's a look at our nice clean foils. Everything's looking real good here. And I'm going to put some more nitric acid on these gold foils. These things look fantastic. It's about 200 milliliters of distilled water. Then I'm going to add an equal amount of concentrated nitric acid here. We're going to put these back up on the heat and let it boil for another hour, hour and a half. The more time we spend here with those foils and the nitric acid, the less problems we'll have later on in the process. It's been about 15 minutes since I added that last dosage of concentrated nitric acid. And as you can see by the fume production there, we've got some more base metals that need to come out of those foils. Stuff here has been boiling now for 90 minutes, 1.5 hours. I'm going to take it down off the heat. I'm going to let this cool down now. And then once we get it cooled down, we'll filter the foils out of this solution. This is the solution that I poured off earlier in the filter. It's been filtering now for a couple hours. It's coming through with just drips down here. Back here, I've put a little bit of ice down in here to cool this thing off, speed things up a little bit. I've got the temperature at 46.6 Celsius, 115.5 Fahrenheit. And now what I'm going to do, go ahead and pour this off now into this same funnel here. This is the nitric acid treatment that I did on this. Boiled it for an hour and a half in the nitric acid. I'm going to add this to the funnel. Take a look at our foils here. I'm rinsing all the foils down into this funnel now with all the other material that we filtered out. And I think we'll be good to go here now. I think all the base metals have been dissolved out. Here's our foils. All I gotta do is wait for this solution to filter, pull through the filter there. I'll have our gold mud and our gold foils in this filter, and then we'll get it out of there, put it in a melt dish, and incinerate it. Alright, I just wanted to look in here and get a close view of what these gold foils look like. They're hollow shells of what they used to be. Gold filled material has a thick coating of gold over a base metal such as brass in this case, and you could not do this with gold plated material. The gold plated material is just too thin and it wouldn't hold up like this. The only way you can get this to happen is with the gold filled material. Shells, hollow shells of what they used to be. Amazing. It's taken me about 2 hours to pull this solution through that filter. Just wanted to show you here that the filtrate is fairly clear now. As soon as I get all this liquid pulled off of this filter here, I'm going to put it in the melt dish and we'll incinerate the gold foils. Alright, I've got the foils in this funnel here. Now what we're going to do is get the foils into this melt dish here. Here, my lack of proficiency is shining through again. If I'd have put one of my special fitted filters in there that runs up the wall of the Buckner funnel, I wouldn't be in there trying to wipe that mud out of there. Alright, got most of it out of there. Now we're going to burn this. Got a low propane flame here, and I'm just going to ignite all of this material, heat it to redness before we put it in the Aqua regia. Incinerating this material like this is critical. It must be done. It cannot be skipped. There are compounds in there that will follow the gold through the refining process and cause problems when we go to precipitate. So burning this material like this will increase our yield and eliminate many problems when we go to refine the material into pure gold. Alright, I'm going to put the incinerated gold foils now into our beaker here. It's almost like a powder. We're going to set this up on the heat now, and what I'll do is add about 100 milliliters of hydrochloric acid here to the foils. That was actually about 150 milliliters. I'm going to add about 1/2 ml of sulfuric acid here. Turn the heat on, and I'm going to start adding small doses of concentrated nitric acid here. That's 3, 6, to start out with. I'm going to add a little bit more hydrochloric acid here. That's about 75 milliliters. Add a few more shots of nitric. I've got 15 milliliters of nitric in there so far. That's 18, 21, and let's hold off here and see what this is going to do. That's 21, that's 24. I got 24 milliliters of concentrated nitric in there now. Alright, let's look underneath here. I can still see some solid pieces bubbling away, so I think we need a little bit more nitric in here. Alright, I think I got 24 in there right now. 24. This will be 3 more. This will make 27. Alright, I've been trying to dissolve this for about an hour and a half now. What I'm going to do is we're going to pour off this solution now and see what kind of solids we have remaining down in the bottom of this beaker. Mostly just looks like sand. Oh, let's see what we got here. I don't know what that is. Some solid material. We do have some solid pieces down in the bottom of my beaker there. I'm going to add a little bit of hydrochloric acid here. I'm going to put this back up on the heat and see if I can get the rest of this stuff to go into solution here. I'm not sure what those pieces are. They might be some pieces of carrot scrap. Just go ahead and hit it with some Aqua regia and see if I can get everything to go into solution. Do a status test on our solution here. You see we got plenty of gold in solution there. I'm adding some more sulfuric acid here to take care of any lead that might be present. Alright, this is working out pretty good. It's only been on there for about 10 minutes. As you can see, most of that stuff is gone into solution. I think those were some kind of pins that had thick tops on them, and it took a little bit longer and some fresh chemicals to get it all to dissolve. I think I got everything to go into solution now. I'll pull this down off the heat. We'll let this cool, filter, and then we'll get a precipitation. I've allowed both solutions to settle overnight. And now what we're going to do is this solution right here is fairly clear, so I'm just going to pour it in to the filter. This solution, it's got a lot of sediment that has settled out down on the bottom of the beaker there. So what I'll do is I'm going to draw that out of there with a pipette here and add it to the filter before I pour the sediment in to speed things up here. Here I'm trying to draw as much of the solution up into that pipette as I can without disturbing the sediment that settled on the bottom of that beaker. Now that I've got most of the clear liquid poured through the filter, I've got some sediment in the bottom of this container, and now I'll pour that into the filter. If I was to try to pour this sediment in initially, then what would happen is the filter will get plugged up, and then the filtering operation slows way down. So it's best to put the clear liquid through the filter first, and then add the sediment. Just filter the sediment by itself, because it's going to slow down now when it plugs up with all that fine sediment. This is what the sediment looks like. Just going to rinse this out real good to get on the gold bearing solution. Rinse out of that sediment and down into our flask down there. I've got everything rinsed out of that sediment. What I'm going to do now is take this filter. I want to save it, because it could contain some precious metals. Take it over here and put it with the rest of my filter paper storage over here. I just kind of heap it into a pile up here. Save these filters. One of these days I'll process these filters and get any precious metals that they contain. Here's our gold bearing solution. It's got a little bit of cloudiness to it, but that's okay for this first precipitation. I'm going to add it to this large 2-liter beaker, and then we're going to put some sodium metabisulfite in here, precipitate out pure gold, and get a yield. I do see a little bit of silver chloride coming out of this flask. I was hitting this solution pretty hard with nitric acid to get everything to go in solution. So there may be a little bit of excess free nitric in here. I'm going to add a few crystals, about a half a teaspoon here of sulfamic acid. See what kind of reaction we get, if any. Alright, those sulfamic acid crystals are just kind of sitting there at the bottom of the container. If there was a whole bunch of excess free nitric in here, we get a lot of fizzing and bubbling going on, and I don't see any of that going on. So fairly certain that there's not all that much excess nitric here. Here we go. I'm going to add some sodium metabisulfite to precipitate out the pure gold. should just about do it. I allowed this gold to settle for about 4 hours, and there's a neat looking little configuration up there. I've never seen that before, hanging off the top of the solution there. I don't know where that came from, but anyway, here's our pure gold that we've got. Looks like a pretty goodly amount there. And I'm going to get this out of this green liquid now. We're going to get this melted up into a butt. I'm going to filter the gold out of this green solution. And then once I get it filtered out, I'll get it into a melt dish and we'll melt it up into a button and see what we got for a yield. Alright, I got most of that solution filtered out of there now. It's about 1 liter of that green liquid poured through that little tiny funnel. And now we got to look at our gold up here. That's our gold mud that we precipitated out. Looks pretty good. It looks like a lot when it's in a beaker like that, but it's not really all that much. It's probably going to be 8, maybe 10 grams or so. It could be deceiving when it's in the beaker. Looks like a lot. I'm going to rinse the gold with some hydrochloric acid here. I'm trying to duplicate exactly what we did with the last video that produced that ugly looking gold button here, to see if we can do a comparison with this now that we've incorporated the incineration in the process. Notice how the filter has turned a yellow color. It wasn't yellow earlier. That's why we rinse with the hydrochloric acid. I believe that yellow color is from iron. And just rinsing with water doesn't get the iron out as good as the hydrochloric acid will. Here you can see that the hydrochloric acid coming out of the bottom of the funnel there through the filter has a yellow tint to it. That means that hydrochloric acid is rinsing some dissolved metals out of our gold. Now I'm going to rinse the hydrochloric acid off with some distilled water. Okay, here we go. We're going to transfer this gold into a melt dish here. And then we're going to take it over to the bench over here. We're going to melt it up into a nice button. Cover it with some borax so that the paper doesn't fly out of there. That borax will glue it in. And we're going to start to melt. Oh my goodness, look at the difference in the surface of this compared to this one. Here's the original one from the gold-filled watches. This one is from the 5 pieces of gold-filled jewelry that I did. And this is the button that I just melted from the 417 grams of gold-filled material. Now if you notice, you'll see this one here, I incinerated this material before I dissolved it in Aqua regia. This one here, I did not incinerate. If you look at the video that I did of 5 pieces of gold-filled jewelry, I made an error in that video and I did not incinerate the foils before dissolving in Aqua regia. And that is one ugly looking piece of gold. It's pure gold, probably 97-98% pure. But it doesn't look anything like this one or this one. This one here is almost 3/9 fine. It's got a little bit of flux clinging to it on top there. But this one came out real nice. And this is a prime example of why it is so important to incinerate that material before we put it in the Aqua regia. Okay, here's our gorgeous pure gold button from the 417 grams of gold-filled scrap. I haven't weighed it yet, so here we go. We're going to throw it on the scale. And we've got, look at that, 19.7 grams of pure gold from that 417 grams of gold-filled scrap. Well, this will conclude the video. I got 19.7 grams of pure gold from 417 grams of gold-filled scrap. I used approximately 1.3 liters of concentrated nitric acid in this entire process. But I think the results speak for themselves here. In the video where I neglected or forgot to incinerate the foils before I dissolved them in Aqua regia, produced a very ugly looking piece of gold. And then the other 2 buttons look more like gold. The point of that is incinerating the foils before we go to Aqua regia is so important here. I hope that point gets impressed upon you by viewing these last 3 videos that I'm putting out on the gold-filled scrap. One more thing, I'd like to say thank you to those who have made contributions to my PayPal account. I've been so busy, I don't have the names available to me of who contributed, but you that did, you know who you are, and I want to say thank you for finding the kindness and having the means to give me those donations. I appreciate that. That keeps the lights on, it keeps some food on the table, keeps a roof over my head, and keeps my fume hood running so that I can continue to produce these quality videos on refining precious metals. Well, that'll do it. Thanks for watching.